Greetings, class, and welcome to week 13 of CIS 4670 here at Cal Poly Pomona. This week we're going to be looking at social engineering and the pitfalls that pertain to it, as that is entitled in the Security Plus book, Social Engineering and Other Foes. So let's go ahead and get to it. So the chapter focuses on comparing and contrasting technical attacks versus non-technical attacks, physical controls versus logical security controls, and the different types of methodologies that are used to employ them. So the Security Plus course basically will give you situational questions, and then it will ask you, hey, what is the best way to effectively combat this? Is it with a logical control? Is it with a physical control? It may give you specific examples of logical or physical controls. And you have to understand how to address social engineering in this framework. So by definition, social engineering is the process where an intruder is going to gain access to something by getting it from someone. And that interaction can be face-to-face. It can never be face-to-face. It just depends. There are a lot of different deployments or attack vectors that social engineers can now use in the prosecution of these types of attacks. So they give some examples here: shoulder surfing, dumpster diving, tailgating, impersonation, hoaxes, whaling, which is one of the best ones. I like to give an example of whaling is where you basically act like somebody you're not. Good examples of that would be movies like Catch Me If You Can, Leonardo DiCaprio, who impersonates a pilot, or any of the many oceans movies that are out there. And then there's phishing or video phishing, or virtual phishing, where this is basically like cold calling. So why social engineering? You can basically take advantage of people, especially here in the United States. I hate to say it, but my fellow countrymen, a lot of us are just really naive. We're very trusting individuals. We're very trusting souls. We do not have that sense of fear, that sense of skepticism, if you will, that questioning mentality. At least a lot of us don't. So we're very susceptible to authority, intimidation, social proof, consensus, peer pressure, urgency, and even with people building trust with us. Oh, I didn't believe he was going to steal from me. I trusted him so much. Police officers hear this all the time. It goes to the fact that social engineers are typically pretty good con artists in their own right. One of the things that social engineering will try to do is overcome physical security via access controls. Now, these can come in the form of locks, of physical barriers, key cards, multiple barriers. Again, think security in layers. So having one or more physical barriers is always really good. You see this more outside of the United States than you do inside of the United States. For anybody who is a veteran and was deployed overseas, the physical rings, the physical control rings of getting into a base, into a area of a base, and then into command and control areas, it's very stringent, right? So same type of thought mentality there. And here in slide 6, they just kind of go over what a diagram of a physical control or physical access may look like. So you have a barrier like a fence. You can have that perimeter guarded by video cameras. You can have security guards walking the perimeter. You can have guard dogs walking the perimeter. You have motion detectors. You could have physical security controls, whether they're locks or keys, card scanners, etc. And then you can have an interior control like a man trap or a locked door or something else that guards against your data center, for example. All right, so hardware locks and security involve applying some sort of physical barrier against something. Now, these can be padlocks. They can be biometric locks. They can be scan locks, etc. Man traps, these basically require visual identification before we let you into somewhere. Man traps also employ a lot of biometric controls, hand geometry scanners, fingerprint scanners, retina or iris scanners, things like that. All right, so hardware locks, some of the oldest physical security devices in existence. All right, and here we see a good example of that on the back of a PC. Great. Probably unlock that master lock within about 2 minutes with my lock picks. Or if I'm really wanting to go through fast, I'll just bring a cable cutter and cut that cable right there, and well, all done. So hardware locks and physical controls are meant to be a deterrent against your theft of opportunity. More so than someone who is very determined to steal whatever you're trying to protect. So, again, these are just different types of security controls on the physical realm. We kind of went through them a little bit. They're barriers. They're physical barriers. They prevent you from getting from point A to point B. And they come in all shapes and sizes, all complexities, and all price tags as well. So biometrics, like I mentioned, you see these used a lot in man traps. They use some sort of unique biological trait to identify a person, but they are susceptible to their own issues. You know, what if I have a hand geometry scanner, and then all of a sudden I'm in a horrible accident and I lose my hand? Well, that's not really good, is it? Or simple thing like a fingerprint scanner, and I scrape up my fingers and my fingerprints are filed down, or they're burnt, or I have some sort of other abnormality, physical abnormality. So you can see where this kind of comes into a little bit of an issue. You can also have motion detectors, alarms, and distribution protection systems. That's just basically what we're saying there is defense in depth, many physical barriers or physical controls. Environmental controls. Now, environmental controls are good too, because if as an attacker I can compromise, say, your HVAC, your air conditioning. If I can shut down your air conditioning for a data center and have all your stuff overheat and shut down your systems, well, that's a really good denial of service attack, isn't it? Fire suppression as well. EMI shielding, electromagnetic interference shielding, is also very, very, very important. We have to watch out for that. EMI interference can come in the form of a lot of different mechanisms. It could be dedicated, where we have EMI generating devices, or it could be very innocent, like a motor that's giving off EMI, and that would distort a digital signal that we see here in the example. Fluorescent lighting is another good EMI source that we have to kind of battle. But we see a lot more LED lighting going in, which is not going to have any EMI in it as well. Plus, it's more cost effective and energy efficient. There's my green plug for the day. So, products that solve a lot of these electrical problems: surge protectors, power conditioners, backup power, uninterruptible power supplies, anything that is going to prevent a surge or damage to the electronic components of our systems. So we just have a kind of a few examples here. Surge protectors protect against spikes. Power conditioners are active devices that effectively isolate and regulate voltage in the building. You could even say that a UPS would fall into that category, and backup power is going to be either battery banks or an entire generator. All right, so how do we protect hardware against this? Well, typically what we need to do is some sort of EMI, electromagnetic interference shielding, and also frequency interference, radio frequency interference. These two things can really cause havoc from a denial of service perspective. The process of preventing electronic emissions from your computer from being used to gather intelligence and preventing outside electronic emissions is also key. Here we want to look at the footprint that our systems are putting out there. Do we need to have a wireless card? Do we need to have Bluetooth turned on? Do we need to have our infrared sensor turned on for a point-to-point communication? If the answer is no, then turn them off. Also, they touch upon hot and cold aisles. Hot and cold aisles you see in data centers a lot, where HVAC, the air conditioning is blown up from the ground, and it is sucked into the front part of the rack, typically where the device fans are pulling air into the system. And on the back side of the racks, the hot air is being pushed out into the hot aisle and then sucked up into the ceiling. Of course, the heat rises, and then pushed out of the environment altogether. It's a very efficient heat exchanging system that you see in a lot of data centers. So understand what a hot and cold aisle system is. And they have a good example of it here on slide 15. So we have the cold air coming from the floor, going through the rack, and then kind of have a heat exchange, and then it goes up to the air conditioning unit, and it's turned back into cold air. It's condensed and everything else. Well, pretty simple here from a social engineering and physical security standpoint for this chapter, chapter 10. Again, let's just take a look here at the syllabus. We don't have anything due this week. Homework 5 is due next week. Homework 5 is due next week. And just since we have a little bit of time here, let's take a quick look at that. All right. So here, again, carnivore, I think I mentioned this last week in last week's lecture. This is a good little analysis, critical thinking homework assignment. It shouldn't take you too long to do it. Just don't forget about it. I had a lot of students in my previous semesters. They get towards the end of the semester and they're like, "Oh, I don't need this 20 points." You fight for every point, please. So anyway, I'm going to wrap up this week's lecture, and we will talk to you next week in week 14. This is Dr. Brown. Talk to you later.